Okay, here we're asked to graph a line given its equation in slope-intercept form, but this time our slope is a fraction. Now remember, our slope-intercept form means that we've already solved for y, so what we're going to do is we have, again, we're going to pick some x. We're going to put in some x, and we're going to do something to it. This time we're going to multiply it by -3/4, and then add 2 to it, and we're going to come out with some y. Okay, I'm going to show you two different ways to do this. The first way, again, is the table method, where we're going to plug in certain values for x. We're going to find out their corresponding values of y to give us a point. We're going to plot those points, and then we're going to draw a line through it. Okay, so let's start. I'm going to go ahead and make a little table. Again, this is the table method. Take my x, multiply it by -3/4, add 2, figure out what my y is, and then pair my x and my y together to get a point. Okay, in the previous problem where we didn't work with fractions, we just kind of plugged in any number that was close to the origin. Now I still want to stay close to the origin because I don't have to go out too far beyond on my x and my y axes, but the most convenient thing to do is to pick x's that are multiples of the denominator, multiples of 4. So again, the numbers that are closest to the origin, I'm going to pick -4 and +4, and then I like picking 0 because that makes things go away and simplifies the equation a lot of times. So let's go ahead. My -4, I'm going to take -3/4, I'm going to multiply it by -4, and I'm going to add 2 to it. So the 4's cancel, so I simply have a -3 times a -1 gives me a +3, plus 2 gives me a 5, so my pair is -4 and 5. Now remember, be careful when you're canceling out to keep track of your positives and negatives and whether you're multiplying by two negative numbers or a positive and a negative number. So still be careful, be mindful of what you're doing there. Let's take my second point, x. I have a -3/4, multiplied by 0, add 2 to it, and I just get 2. So my second point is 0, 2. And my third point, I'm going to plug in 4. So I have -3/4 times 4, plus 2. This time my 4's cancel, and I have a -3 plus 2 gives me a -1. So my point is 4, -1. Alright, let's go ahead and start plotting them. My first point, -4, 5. So I'm going to go -4 on the x-axis, 2, 3, 4, and then +5, 1, 2, 3, 4, 5. Then I'm going to plot my second point, which is 0. I don't go anywhere on the x-axis, but I go up 2. And then my last point is 4, 1, 2, 3, 4, and I go down 1. And there's my line. Okay? Now that's if I wanted to use the table method. For the slope-intercept method, we already have some pieces, since our equation is already given to us in the form y equals mx plus b. Remember, and our m is our slope, and our b is our y-intercept, meaning where it intersects the y-axis. And our equation was y equals -3/4 x plus 2. So our slope is the coefficient of our x. It doesn't include the x, it's just, so our slope is, I'm just going to use the letter m to remind ourselves, it's -3/4. Our y-intercept is 2. So that is 0, positive 2. Okay, so let's go back to looking at our slope. It says negative 3/4. So remember, the numerator of our slope tells us whether or not we go up or down. And because it's negative, it means we go down 3 places. And our denominator, 4, is positive. It tells us that we go right 4. Now let me just pause for a moment here to remind you, this negative 3/4 is the same as negative fraction 3/4. And I have one negative sign, so I'm either going to assign it to my numerator or my denominator, but it doesn't go with both. Okay, and my y-intercept here is the point where I start. So I'm going to start at this point, and then I'm going to move down 3 and right 4 from that point. So let's go back up to our graph, and it said we're going to start at 0, 2. So let's see. I'm going to start at this point, 0, 2. And then I was going to move down 3. So I moved down 1, 2, 3. Right? Down 3. And I'm going to move right 1, 2, 3, 4. Right 4. That gives me this point. And if you notice, it's the exact same line that I had drawn that we just found using the table method. So either one of these methods works, and depending on what ALEKS is asking, you can plot it either way.